going to take a few moments to review the posted solution for the catering management system, data model exercise, and we'll also look at the instructions for the first part of the project work as well. So coming here to examples and solutions, here's the first one for that data modeling exercise. Now I emphasized that it was one possible solution because there's often more than one correct way to model something like this. And this is, as I said, just one. And looking at the students' work that's been submitted, actually there are very many that are almost identical or even identical to this. So I think the students were pretty close in terms of nailing this down themselves. So just a quick discussion or description section down there. So basically we see that the customer's in a one-to-many with function, so it's function type. Well, that is something we often call more of a lookup value than anything else, the function type, but it is a one-to-many relationship between it and function as well, right? Now, that's all that we're modeling in the very first part. We're going to be adding the other entities as time goes on, right? So then, of course, we'll have the one-to-many. The function can be made up of multiple function details, right? And it's really the detail is the hub of much of the work, right? Because the function details, that's where we associate all the three of these many-to-many relationships. Just looking ahead, the next one we're going to add is the room to function detail. And so we don't have a better name, so we'll just go with a concatenation of basically the names of the entities. Mind you, I left out the word detail. I thought it was superfluous. So just simply function room, and a function detail might have multiple rooms involved, so we'll just probably use check boxes or something like that to check off, you know, this room, that room, and the other room that's involved in that function detail. Now, another somewhat different relationship is the function and equipment, right? So there are multiple pieces of equipment involved in a function, and vice versa. A function will have multiple pieces of equipment. But notice the difference, of course, here. This is the only thing, the only data in the function room is what's necessary to support the many-to-many between function detail and room, right? Basically, the two foreign keys comprise the primary key. That's the only one like that in this diagram. The function equipment associative entity it still supports the many-to-many between function detail and equipment, but we don't use the foreign keys as part of the primary key. Instead, it will have its own separate primary key to identify each record here, mainly because it will also track quantities and charges for equipment. In other words, extra data will be put inside this entity, kind of describing, in a sense, the relationship between a piece of equipment and a function or function detail, right? Okay, and we have a third, okay, that we'll eventually add as well, but that won't be till a little bit later on. We'll be adding the many-to-many between the staff working the function detail and the function detail itself. Once more, many-to-many going through this associative entity, which we're just going to call work, right? This is the one where the work will also track. Notice that we aren't using the straight lines here. This is not a simple composite primary key. This will have its own primary key, just like a function equipment, because we're storing additional information here, like how many points the staff member gets towards earning gratuity from the function and so on. Okay, now there's a bit of a twist. There is no relationship to deal with for alcohol service, right? Instead, I would think we would probably go with a Boolean property in the function detail, right? Just true or false, is there alcohol service involved, right? And good catch if you figure that out is what I say here, right? Now, looking at the model, some students also had, and it's perfectly correct, the lookup for function type related to function detail, right? You might have one choice for function, right, the type of function it is, but each function detail might have a refined, more detailed information about the type, and it could all be stored in this function type. So I would definitely accept that arrangement or that model. Equally as valid as the one that I have shown here, right? Because in the instructions I mentioned things like function details might be a lunch and then awards presentation, something like that, right? So I can't argue with that. That's a perfectly valid way to draw this as well. You might consider having separate lookups for the function type for the actual function and the ones for function detail. That would be a third valid approach that you could do. So this, like I said, it's only one of the many possible solutions that are all equally valid. But that's enough to get us started in the course, and we'll follow this more or less. We might change to having the function type a lookup for both. I haven't quite decided about that yet. Got to keep you in suspense, right? Okay, well, that's our solution to our data modeling exercise. Okay, what else do we have up here? Well, of course, under assignments, we have project part 1A, right? Aim to have this completed by Monday of next week. Now, that's an aim. It's not a due date, right? You don't hand it in. You won't hand it in until all of part 1, A and B, is completed. And don't even have the instructions for part B released yet. That'll come after a couple more videos are posted up in our content, right? By the way, I usually note here that the material or lessons required for this part are covered in steps 1 and 2 in the actual video, right? Okay. All right, so let's just have a look at the instructions here. So here is what you're going to do, right? So for our catering management application, I ask you to use the name, put your Blackboard username underscore catering underscore management. That should be the name of the project, right? That way I can identify it by your Blackboard username. It is a simplified model of our catering management solution. We're just starting with those 3 entities, okay, that were in the upper left corner of our overall model, right? Just the 2 simple one-to-many relationships. Customer and function type both are on the one side, and on the many side is function, okay? Now, what I've done is I've given you, okay, in the modeling exercise, we didn't ask for properties or details about the entities themselves, right? So here I'm giving you some I want you to work with for consistency. So the customer is really just made up of the 3-part name, first, middle, and last. A company name. Now notice that's not required. That's optional because it might just be a person. It might not actually be a company, a corporate client, right? A phone number would always be required. And then we're going to have a customer code, right? Now this is just to introduce some fun and have a bit more of a challenge to the exercise. So it will have 1 capital letter followed by 7 numeric digits, okay? And it will be unique. No 2 customers can have the same customer code. Now I've given some detail here that the customer code will start with one of these letters, C for company clients, G for government, et cetera, internal and all others, right? Okay, so that's going to be our customer code. Then we have the function type class, the other parent in this little family you see reflected here in the diagram, and that is a simple ID and a name, right? ID is the integer identity primary key. Then we have the function class itself, okay? So we have a name, right, for the function, lobby sign, okay? You might not have thought of that, but that's something that's always required here for any kind of a function hosted at a hotel. You know, what name or information do we want to put on that sign that we stick out in the lobby of the hotel directing to the Smithers wedding in room 107 or whatever, right? So that's what goes on the lobby sign. Obviously, there's a date. We're going to put in a duration, how many days long this function lasts, or maybe it's all over in 1 day, in which case the default of 1 would be perfect, right? We'll validate that it's greater than 0. We'll have a base charge, okay, as well as a per person charge. And along with that, there's a guaranteed number, right? Those are all required, and the guaranteed number has to be greater than 0. The default is 1, just so it's not 0. And then that way we'll actually put in the guaranteed number. Now it's usually agreed in a contract of some sort. By the way, how guaranteed number works in the real world, it's sort of the minimum that you're going to charge, right? You have to guarantee so many people. And if you have more than that, it's not free. You still pay the per person charge for everyone that actually comes, right? If there is a per person charge, depending on the type of function it is. But the guaranteed number means even if you have fewer people show up than the guaranteed number, you pay the per person charge for the guaranteed number of people, right? So it's like a minimum charge ends up. SOCAN, SOCAN, I'll let you look that up. Just do a quick Bing search or Google search. You'll find out that it's a standard fee that hotels and so on charge for playing music. Music is copyrighted in the real world, so this is how the music producers and artists and everyone else gets paid when a client uses their music, and whether it's at a wedding reception or a conference of some sort, whatever, right? There will be a standard SOCAN charge, right? Deposit, obviously, has the deposit been paid would be true or false, and options for avoiding, they don't have to pay the HST, they don't pay gratuity, those could be true or false as well. Last 2 we have there are the 2 foreign keys, right, for those other parent objects, the customer and the function type, right? So they're required integers because we're using integer identity primary keys in the other 2, okay? All right, that's basically the layout, okay? Make sure that you supply error messages and display names as required in the data annotations that you add to your classes. Right? We're going to make the DB context. I want you to give it this specific name just for consistency. Catering context. And some things, as you know, we can do with the naming conventions. For example, having ID as the primary key is automatically recognized, or it could also be the class name ID, right? And of course, then we're going to use the data annotations extensively to add additional validation and feedback to the user, display names, and so on. That's something else I should maybe talk about. This business of this customer code, well, that's an opportunity maybe to stretch your mental legs here in terms of coming up perhaps with a regular expression. In our medical office, we examined how we could use a regular expression to guarantee that the correct characters are typed in for a valid OHIP number, for example. The right number of characters and the type, well, in that case, all digits. Okay, in this case, we have one capital letter followed by 7 digits, right? So that would be a chance to play around possibly with a regex, but that's not the only way, right? That's not the only way you could enforce referential or integrity, validation, I should say, on the customer code. We also talked about I-validatable object, right? And because this is fully contained within the class, we could write C# code to actually do the validation, right? With much more, rather than using a regex, with much more access to all the capabilities of the C# language to decide if it matches this necessary pattern. So I would accept either answer as being correct, either doing it with a regular expression or with I-validatable object, okay? Anyway, all right, so finally, the Fluent API will be used to do additional things, such as the unique constraint in the customer code, the cascade delete being prevented, so we restrict cascade delete on both of these primary foreign key relationships, right? Make a migration, create the database, right? And then we need some seed data. It's always important during development to create or have some seed data automatically inserted into the table. So in each of these 3 tables, I have to ask you to make sure that you seed some data in, but we went through that demonstration in the medical office example with doctors and patients. By the way, remember, and this is a common mistake, students think they know it and then they forget when they go to do it. There's an order, right? An order required, okay? Which of these 3 classes has to have data inserted first? Okay, trick question. There isn't one class that has to have it first, but there's one that has to have it last. And in this case, it's the child, the common child of the 2 parents. So the function class, you can't insert data there until you have data in both customer and in function type. Only then can you put data into or seed data into the function class, right? So just remember things like that, okay? You'll get some seed data in place. And then I'm going to ask you to go ahead and scaffold the controllers and functions for all 3 entities, customer, function type, and functions, right? Finally, just add navigation properties to the menu system so I can quickly and easily go and look at them. And that's it, okay? All right, note there that only adds up to 60 marks. The final 40 marks will come from part 1B, right? So the whole thing will be worth 100 marks when you hand it in a couple weeks, right? Okay, so I just note there in general, I don't always break down, oh, there's marks assigned for this detail and that detail. Some of it is just assumed that you have to get certain things done. For example, creating a migration, updating the database, and so on, right? Providing links so that you can find where you're at in the navigation system and all that, right? Failure to do it can result in marks being subtracted, but it's just so necessary a part of building an application and not giving specific grades for those individual steps. Okay, so that's basically how the project part 1A works. So hopefully running over that will give you an idea of what the expectations are. So get started on it right away. Of course, what will help is going through the posted videos based on the week 2 folder. Okay, so we have videos to go along here, videos 2.1 to 2.4 from our playlist, cover all medical office steps 1 and 2, where we add all the models, the migrations, etc. Okay, following this 3-step process, using naming conventions as much as possible, then data annotations, and finally the Fluent API, right? Then we have discussions up online about this PowerPoint on link. Then we get into the next step, okay, of the part 1 of the database development, and that is actually adding that I-validatable object and the database error handling. So just a reminder that each of these sections in the weekly folders, you'll find these copy-paste files, right? So these are the ones that I'm using during the demonstration. So I'm making them fully available to you as well. It helps you to follow along with the demonstration, right? There's often extra notes inside here as well as the code that is utilized in the application. So using this, you should be able to recreate the application on your own. However, right? However, of course, here under content categories and right there with examples and solutions, I've already started to post the code that I built during the demo, right? During the construction of the demo application. So this has got everything concluded to the end of part 1A. It's already there and ready for you to download. All right. So this was just a discussion basically of some things we covered in our office hour earlier this morning. By the way, the office hours are turning into basically a synchronous class so that you can come and participate in the class and get the benefit of doing that as well. All right, bada bing.